Good afternoon, class. We are looking at section 4.4, optimization. Or optimization problems from chapter 4, application of the derivatives. Let me grab the laser pointer here. So again, reminding you of the various differentiation formulas from the definition to basics, product rule, quotient rule, chain rule, exponential rules, and others. Delta y versus dy. Delta y by definition f of x plus delta x minus f of x, and dy is f prime of x dx. And if you have a point, you can find the equation of a tangent line at that point, known as linearization. Also, the definition of a mean and max, local or relative extreme value. Extrema is the plural of the Latin extremum. A local minimum is the minimum value within some open interval. Local minimum occurs at the point C in an open interval of A to B in the domain if f of c is less than or equal to f of x for all x values in the open interval, in some interval. A local maximum is the maximum value within some open interval. Local maximum occurs at the point C in an open interval of A to B in the domain if f of c is greater than or equal to f of x for all x values in the open interval. So as we look at these two graphs, local mean, local max, local mean, local max. Absolute or global extreme values of extrema are either maximum or minimum points of a graph. Absolute minimum occurs at the point C if f of c is less than or equal to f of x for all x values in the domain. And that's the key, all. That's the case for absolute max as well as the mean. Absolute minimum occurs at the point C if f of c is greater than or equal to f of x for all x values in the domain. If you look at these two graphs, local mean, local max, local mean. Peaks and valleys are local. This one is an absolute minimum because no other point has a smaller y coordinate. Local max, local mean, local max. This local max happened to be an absolute max because no other point has a larger y coordinate. A critical point defined as such, a critical point of a function f is a number such that f prime is either 0 or does not exist. And the steps are find f prime, set equal to 0 to find the solution, and where it's undefined or does not exist. Now, the extreme value theorem or closed interval theorem method, which pertains to a continuous function in the closed interval of a to b, find the critical points, f prime equal to 0 or does not exist, find the functional value at the endpoints a and b as well as c1 and c2, and absolute max is the largest value, absolute mean is the smallest value. How derivatives affect the shape of a graph? We've discussed that. A function f is increasing where f prime is positive, decreasing where f prime is negative. So it looks almost like a line with a positive slope, increasing, a line with a negative slope, decreasing. A critical point, as it was mentioned, is a point where f prime is zero to exist. A relative max or relative mean is a critical point at the top or bottom of an interval of a graph, meaning peaks and valleys. The function is concave up, where f double prime is positive, meaning f prime is increasing, and a function is concave down, where f double prime is negative, that means f prime is decreasing, looking like this, concave up, looking like that, concave down, and an inflection point sees a point where concavity changes. Inflection point occurs where f double prime is 0, or f double prime does not exist. Okay, concave down becomes concave up. This is the point where the change occurs. And now 4.4, optimization problems. Optimization problem is the problem of finding the best solution from all feasible solutions. In other words, find a solution in the feasible region which has the minimum or maximum value of the objective function. Examples: maximize profit, minimize cost, maximizing area enclosed, etc. First derivative test for the absolute extreme values. Suppose that C is a critical number of a continuous function, f defined in an interval if f prime is positive for all x less than c, and f prime is negative for all x larger than c, then f of c is the absolute max value of f or f of x. If f prime is less than 0 for all x less than c and positive for all x larger than c, then f of c is the absolute minimum. So what is that? Basically, what it says, when you do the first derivative test, remember we do the first derivative test with the sign graph. Okay. The first derivative test for absolute extreme. A local extremum is an absolute one if it's the one and only extreme. So if you happen to have one extreme, and if you happen to have an open interval, local becomes absolute. That's all it says here. Second derivative test for absolute extrema on an interval. If there's exactly one critical number, let f be continuous in an interval, open interval of a to b, with only one critical number c in the interval. If f prime of c equal to 0 and f double prime of c is positive, then f of c is the absolute minimum of f on the open interval of a to b. If f prime of c is equal to 0 and f double prime is less than 0, then f of c is the absolute maximum of it on that interval. The idea is this: when f double prime is a positive, it's concave up, that means minimum. When it's negative, means concave down, that means maximum. That's all there is to it. Look at a couple of examples. A farmer has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. He needs no fence along the river. What are the dimensions of the field that has the largest area? Well, we can draw something, make things up, the width of 100, the length of 2,200, 700, 1,000, and so on, and just guesstimate. But that's not the proper way. The proper way is that we don't know. We're going to define variables. So we're going to define the width to be x, the length to be y. So the objective is to get to the maximum area. So if this is x, this is y, then we want to maximize the area, which is x times y. And what is the constraint? So this is the objective function. What is the limiting factor or the constraint? Is that we have 2,400 feet of fencing. So when you look at this, the perimeter is normally x and x, 2x and 2 plus 2y. But one side is a river, we don't need it. So normally 2x plus 2y, but in this case, only 2x plus y. And that's 2,400. So just understand why. That's why when you do applications, drawing is important, defining variables is important. X represents the width, Y represents the length, A represents the area. And so the process is this. When you look at this one, it has two variables. You want to make it one variable. So you solve for one of these variables and you put it in there. Normally we solve for Y. We put it into that. And so the function A, which has two variables, x and y, now becomes A of x. The 2,400x minus 2x squared has one variable. And x is between 0 and 1,200. Here's the reason. X represents dimension, must be positive, can't be 0. And y is less than 1,200. If you set this one equal to 0, This gives you 1200. So it has to be less than that because if it's equal to 1200 is 0. And if it's larger than 1200, this expression becomes negative. And so you have an open interval of 0 to 1200. So let's differentiate to find critical points. So here's a of x. It's easier to use this one. We get a prime of x equals 2400 minus 4x. To find the critical point, we set this equal to 0, and it becomes 600. So we have an open interval with one critical point. Whether we do the first or second derivative test makes no difference, but understand local becomes absolute. So let's start with both. I'm going to go with the first derivative as well as the second derivative test. Just for practice, we're not going to do both for every question. So for the first derivative test, I need a sine graph. So I go from negative to positive infinity at 600 is 0. And to the left of 600, if you plug in, okay, such as 0, you get positive 2400. To the right of 600, I don't know, put 1000 and you get negative. So up arrow, down arrow. So the maximum occurs at 600 if you go with the first derivative test, but you have to do the sine. The second derivative test is that you evaluate it, you get negative 4. Now you have to plug it into this one. Because it's independent of x, a double prime of any number is negative 4. When a double prime is negative, means it's concave down, means you have a maximum. So because this is negative, it's CD, concave down, looking like that, so you have a maximum. So I hope you recognize this is easier. So maximum occurs when x is 600. Put it into this one or this one, but it's better to go back to the original given because we don't want to make a mistake. And we find the missing y becomes 1200. What would be the largest area? X times y, 600 times 1200, which is 720,000 square feet. So to recap, you draw the setting. You define your variables. You have an objective function, in this case, the area, to be maximized. And then there is some limiting factor, the constraint according to what you have to follow. And then you solve for one of the variables in the constraint to make this one a function of one variable. Now you go with differentiation, finding the critical point or points, and then first or second derivative test will do the job. Find two numbers whose sum is 80 and whose product is a maximum. First, we're going to define the variables. We don't know the numbers. Let's call them x and y. What's the objective? Maximize the product. So maximize the p equals x times y. We're going to use p standing for the product. You can say f of x. F. It's not f of x yet. The sum is 80. That is the constraint. That is the limiting factor. So x and y must be 80. We go to the constraint and solve for y. We put it into this and make it a function of one variable x. So p has two variables, x and y. If we change the y to 80 minus x, now it has one variable. Always you have to come up with the domain. The reason the domain is 0 to 80 is as follows. We want the maximum of the product, right? If x is 0, makes the product 0. So it can't be 0 because it won't give us the maximum. What if it's negative? Because the sum is 80. If one of them is negative, the other one is positive, their product is negative. What about 80? If you choose 80, y becomes 0, their product becomes again 0. So that's why this is the open interval of 0 to 80. And so differentiate AD minus 2x. Set it equal to 0 to find the critical point 40. All we did, we found the critical point. Is this going to maximize or minimize? Let's go with the second derivative test. P double prime is -2, and you have to plug in 40, but it's independent of x, so you don't have to. It's always negative. It's always concave down. So it looks like that. So it's a local max because it's an open interval, one critical point, it's an absolute. So max occurs when x is 40, plug it into this, y becomes 40. Also, the product is 1600. A farmer with 240 feet of fencing wants to build an E-shaped enclosure besides a creek. As seen in the diagram, find the maximum area. Notice it's given to us, the drawing. If it's not, we have to come up with our own. So let's define our variables. X represents the width, Y represents the length, A is the total area. We want the maximum area. The objective is to maximize the area, X times Y, X times Y. The constraint is that we have 240 feet of fencing. So I hope you recognize that we have X, 1, 2, 3. So 3 times X. So in essence, this is X, this is X. We have 3 of them. So 3X. But Y, we don't need it on this side. 1Y. So 3X and 1Y. They must add up to 40, 240. That is the constraint. So 1, 2, 3X, and there's only 1Y. Just again, the process is simple. We're going to solve for Y because A has 2 variables and we don't want it. We want it to be 1 variable, a function of 1 variable. Y is 240 minus 3X. If I put it in here, it becomes A of X, X times 240 minus 3X. X represents dimension, must be larger than 0. And if you write that X is between 0 and 80, because if you set this one equal to 0, class, this part, X becomes 80. Now, if you pick a number, so it can't be 0 and 80. If you pick a number larger than 80, makes this one negative, and we can't have that either. And so we have our open interval of 0 to 80. We have the function y or f of x or a of x equals 240 x minus 3x squared. We are going to differentiate. So a prime of x is 240 minus 6x. To find the critical point, we're going to set this equal to 0 and so x becomes 40. So we have an open interval with one critical point. We can do the first or the second derivative test. We decide to go with the second because it's easier. A prime is given. A double prime is -6. You have to evaluate A prime at this point. I want you to know that. But again, this is independent. So even at any point, a double prime of any number is negative, makes it concave down, which results in maximum. So it looks like that. So maximum occurs when x is 40. If we replace it here, we get 3 times 4d, 120, and y becomes 120. So the maximum occurs when we have the dimensions 40 times 120. So the maximum area is the product of the two, 4,800 square feet. A box with a square base and open top must have a volume of 32,000 cubic centimeters. Find the dimensions that minimizes the amount of material used. So what we want to discuss, everybody, we want to discuss, this is called a rectangular solid. Here's the length, here's the width, here's the height. Rectangular solid or prism. The volume is the width times the length times the height. Surface area like gift wrapping. So the width times the length, the height times the length, the height times the width. Each one has two of them. For example, the bottom and the top are the same. That's why we multiply by 2. Cube, where all sides are equal, the volume is s cubed, and the surface area is 6 times s squared. Just to remind you of the information about this concept here. So now we have the width and the length to be the same x because the base is square and the height is h. You have to define your variables. So the base is x times x and the height is h. So find the dimension that minimizes the amount of material. So we want to minimize the material. That means the surface area. The surface area is normally, because the base is a square, it's x and the height h, x times h would be this wall, and all of them are the same, 4xh. Those are 4 of them if you go around them. The bottom is x squared, so is the top plus 2x squared normally. But it says it's open top. So we have the 4 walls, 4xh, and because it's open top plus x squared, not 2x squared. So open top means 1x squared, not 2x squared. And the volume must be 32,000. The volume is x times h. So the volume is x squared h equals 32,000. So this is understanding the problem and what we've done so far. Throughout the setting, define our variables and use algebra/geometry to write the surface area, the volume, and so forth. Now we are going to do calculus. As always, this one we want it to be a function of one variable. We have two variables, x and h. So if we solve for h here, that means divide by x squared. And put it in this one, s becomes a function of x only. Replace the h. 4 times 32,000 is 128,000. X goes away. and the exponent at the bottom. We are just doing elementary algebra now. Elementary algebra. And we are going to rewrite 128,000 over x to 128,000 x to the power minus 1, just because we want to be able to go to the next step, which is differentiation. By the way, x must be 0 because it represents dimension, and there's no other piece of information, so 0 to infinity. Everything we've done so far is elementary algebra. Now what do we do? Differentiate. So we are going to differentiate. We get 128,000 times negative 128,000 x to the power minus 2 plus 2x. Remember what we do. We are looking for critical points. That means we're going to look at where this function S prime, 0, where it's undefined. To do that, we are going to combine these two as follows. We are going to write this over x squared. And when we take a common denominator, 2x changes to 2x cubed. Now, S prime is 0. That means the numerator is 0. That means 2x cubed is 128,128K. X cubed becomes 64K or 64,000. X is cube root. When you cube root 64, you get 4. When you cube root 3 zeros, you get 1 0. Remember, that's how it works, right? So you get 40 centimeters. S prime does not exist. That means the denominator is 0. The denominator makes x 0. 0 is not part of the domain, so it can't be. So there is this open interval with one critical point. So that is going to be not only local, also absolute. Is it going to be maximum or minimum? We don't know. So we can do the first or second derivative test. And I hope you recognize second derivative test is much easier. And we're going to go back to this, and I'm going to do erase this part. So I'm going to differentiate this again. I want to go to S double prime. Therefore, the product of these two numbers positive, 256,000 x to the power of negative 3 plus 2. Now, according to the second derivative test, you have to evaluate the S double prime at the critical point 40. So plug it. Now, even if you don't know the answer, and you don't want to even look for the answer, you recognize this is positive, this is positive, this is, the sum is positive. However, 40 cubed, remember it was 64,000. When you divide, you get 4, and 2 is 6. So it's, what I'm interested in is that it's positive. When it's positive, it's concave up. Concave up means minimum because it looks like that. So minimum occurs at x equals 40. Now, x equals 40 goes in here, becomes 40 squared, or 1600, and h becomes that the two zeros cancel each other. 320 divided by 16 is 20. So we get h equals 20. We're done. They didn't ask for the minimum surface area. They just asked for the dimensions 40 by 40 by 20. That's all there is to it. However, let's find the surface area. Let's plug in. And if you do that, you get 40 times 40 times 20 plus 40 squared, which is 4,800 centimeters squared, in case if somebody's interested in that. Find two numbers whose difference is 18 and whose product is a minimum. Define the variable. What are the numbers? I don't know. How about x and y? Let the numbers be x and y. Define your variables. What is the objective? Minimize their product, x times y. What's the constraint? Their difference is 18. So x minus y is 18. If you wrote y minus x equals 18, that works. It's just that the first number becomes the second number and vice versa. You're just looking for two numbers. So P is a function of two variables. You solve for one of the variables and you put it here. If you solve for y, then it becomes x minus 18. Put it into the objective function. And P, which has two variables, becomes a function of two variables. No, one variable, x. What's the restriction? We're going to say it's all real numbers, no restrictions. And here's the reason. You, unlike the previous example that we were maximizing the product, we want to minimize the product. If we want to minimize the product, if their product is 0 is okay, yes. What about negative? That's even better because you're minimizing the product. But when you're maximizing, you don't want negative, you don't want 0. That's the difference. And so we are going to go with calculus. Now that we are done with algebra, we want to find the critical point. So P prime is 2x minus 18. Setting it equal to 0 results in 9. P double prime is just a number. Anytime P double prime is a constant, it makes life easy. And remember, it's positive, means concave up, means we have a minimum. So minimum occurs when x is 9. So if x is 9, put it in here, x minus what number is 18? X minus negative 9. So y becomes negative 9. So plug it into this. And y becomes negative 9. Their product is minus 81. Remember, when you answer a question like that, you say the two numbers, one of them is 9, one of them is negative 9. That's why if you put y minus x here, is the other way around, okay? Y would be 9, x would be negative. And it doesn't make any difference. You just want two numbers. Let's enclose a rectangular area of 288 square feet and then divide it into 3 equal size pens with parallel sides. What dimensions will minimize the material needed? All right. So let's write the objective and so forth by defining our variables first. Let's say the width is x, the length is y. So you want to minimize the material. So x, we have 1, 2, 3, 4. So this is x, this is x, this is x. So we have 4x. Y, we have 2 of it. So you want to minimize the, in this case, P for the parameter 4x plus 2y. That's our objective. Again, 1, 2, 3, 4 sides, each one is X. 1, 2 sides, each one is Y. And we have 288 square feet of area, so X times Y must be 288. That is the constraint. Okay, very straightforward, everybody. So with that being the case, let's solve for Y. Becomes 288 over X. Put it into the objective function because objective function has two variables and we want to have one. So replace the Y. So P of X is 4X plus 2 times 288, which is 576 divided by X, or X to the power of -1. And the reason we write it in this fashion, it becomes ready for the next step. That's why. Okay, everybody. And X must be positive because it represents dimension, and that means an open interval of 0 to infinity. So far, we haven't done any calculus. Now the calculus starts, and we start with differentiating. So we are going to differentiate P of X. We get P prime of X, which becomes 4 minus 576 X to the power of -2. So this is a calculus. And since we want to set this equal to 0 and so forth, we're going to take this down. So this is calculus, this is algebra. Now this is 4x squared minus 576 over x squared. We are taking a common denominator. And so if you set it equal to 0, a fraction is 0 when the top is 0. By the way, if you said f prime doesn't exist, the denominator becomes 0, x is 0, is not in the domain. So this one, 4x squared is 576. Divide by 4x squared is 144. And x has two answers. But dimensions can't be negative. So only one answer is acceptable. So you have an open interval with one answer, meaning local becomes absolute. Now, is this going to minimize or maximize? We don't know. We check it with the first or the second derivative test. And I hope you see that it's easier to go with the second derivative test and differentiate this guy again, this one. You're going to differentiate. This is easier. So this gives you 0. This gives you minus 576 times minus 2. The product is 1152 x to the power of -3, or 1152 over x cubed. Now, the second derivative test says plug in the critical point and figure out it's positive or negative. So when I put 12 cubed, even if you don't evaluate it, you don't have to. This fraction is positive because the top is positive, so is the bottom. That's all you want. You want the sign, positive or negative. Positive means concave up. Concave up looks like that. That means a minimum. So minimum occurs when the choice of x is 12. So you put number 12 into this or to this, and y becomes 24 feet. So we have the dimensions. 12x is 12 feet, y is 24 feet. So we do have the dimensions, class. What is the minimum material? 4 times x, 4 times 12, plus 2 times 24 is 96 feet. If you plug in, you get 96 feet of material, everybody. Okay, from a thin piece of cardboard, 8 by 8 inches, square corners are cut. Then the sides can be folded up to make it into a box. What dimensions will yield a box of maximum volume? What is the maximum volume? Definitely, we need to draw the setting. So we have a 8 by 8. We're going to cut the corners. And the amount that we're going to cut is X amount, everybody. So this is X. That means every corner is X. So if this is X, so is this one. And what is left here is 8 minus 2X, right? Folded up, looks like that. So it's a rectangular solid with the base being 8 minus 2X by 8 minus 2X with the height of X. So the objective is to maximize the volume, which is length times the width times the height. The constraint is based on what we did here. The length and the width are the same, 8 minus 2X, and the X and the height is X. So that's the constraint we are going to plug in. So the volume is the length times the width times the height. So X times 8 minus 2X quantity squared. What could X be? X must be positive, and it must be less than 4. Why is that? If you set this equal to 0, you get 4. Has to be less than that. I just think about this. 8, when you fold it in half, you get 4 on each side. There is nothing left to give you a volume, if you will. There won't be a box if you cut it in half. So it should be between 0 and 4. Now this one is 64 minus the product of these two minus 32x, and then you get 4x squared. So I'm assuming everybody remembers A. Let me write that. A minus B squared is A squared minus 2AB plus B squared. That's what we are using. And we are going to multiply the x. When you multiply the x, you get 64x minus 32x squared plus 4x cubed. And we put it in descending order. That means we put 4x cubed first, minus 32x squared second, plus 64x last. Now, this is all algebra. Now, to go to calculus, we are going to differentiate. V prime is 12x squared minus 64x plus 64. And because we want to set this equal to 0, we are going to factor. So first and foremost, if you look at those numbers, 4 is in common. So if I take the 4 out, I get 3x squared here, minus 16x here, plus 16 here. And this can be factored easily. 3 is a prime number. I leave it for you to convince yourself. So it's 3x and x. And over here, you can put 1 and 16, 2 and 8, 4 and 4. And of course, both of them having the same sign because it's positive. What I want you to notice is this. This is important, class. The product of these two and the product of these two, they must add up to negative 16x. Take a look, and they do. Okay. So there are two answers. Either this one is 0, that means x is 4/3, or this one is 0, that means x equals 4. We've already established this, so 4 is out. And so because 4 is out, we have one critical point. We do the first or the second derivative test. Second is easier. Here's v prime. V double prime is 24x minus 64. If we plug in 4/3 and evaluate, it gives us positive or negative, and we'll see what we're dealing with. We plug in 4/3. 8 times 4, 32. Minus 64 is negative 32. We just want the sign, negative. Negative means concave down, means maximum because it looks like that. So the maximum occurs when you choose x equals 4/3. So what is the length or the width? 8 minus 2 times 4/3, which is 8/3. 8 minus 8/3 is 16/3. Class, this is minus 8/3, okay. And 8 is what? 24/3, so 16/3. So 4/3 by 16/3 by 16/3. What is the volume? 1024 over 27, or 37 and 25 over 27 cubic inches. These are exact answers, class, okay? When you have fractions, don't change them to decimals unless they ask you. So those are the exact answers that we were looking for. A stereo manufacturer determines that in order to sell X units of a new stereo, the price per unit must be this much. P of X equals 1000 minus X. The manufacturer also determines that the total cost of producing X units is C of X equals 3000 plus 20X. Find the total revenue. Remember, we are going to sell X units, and the price is this, so their product, X times P, is the revenue. This is so far elementary algebra. So 1000x minus x squared is our revenue. Profit. Profit by definition, everybody, is revenue minus cost. So that means subtract the cost from the revenue we just found. And this gives us minus 3000 minus 20x. And we can combine these two. And we put it in descending order. Minus x squared plus 980x minus 3000. How many units must the company produce and sell in order to maximize profit? Now, because we are maximizing this function, we are going to calculus and we are going to differentiate, and p prime becomes negative 2x plus 980. Set it equal to 0. Critical point becomes 980 divided by 2 or 490. Is this going to maximize or minimize? We don't know yet. We have to do the first or the second derivative test. And the second derivative test is easier because it's just a constant -2. Remember, when it's negative, means concave down. And that means maximum. That's the meaning of it, everybody. What is the maximum profit? Well, into this goes this x. Put it into a calculator. So minus 490 squared plus 980 times 490 minus 3,000 results in $237,100. That's the maximum profit, everybody. What about price? What price must be charged in order to make this maximum profit? Go back to the price function and replace the x with 490, and the answer is $510.